Hello everyone, welcome to lab 6. In this lab we are going to discuss some interpolation techniques to fit a polynomial equation to a given data set. The techniques will be discussed are polynomial interpolation, piecewise linear interpolation, and cubic spline interpolation. Here you see a general polynomial equation that we discussed in previous lab, and in matrix form we may arrange all the equations. The unknowns are the coefficients of the polynomial equation, which we may represent as elements of a column vector AI. The right side column vector BI is the data points for the vertical axis, and the left side square matrix X is derived from the horizontal coordinates, which is explained in the next slides. Let's begin with an example problem to discuss. We have four data points and we want to determine a polynomial equation that would pass through all these four data points. Let's say the first data point is x1, y1, the second one is x2, y2, and so on. Now we are about to generate the polynomial matrix from our x data points. You already have seen this general equation where p refers to the elements from the vertical axis data points. To generate the 4x4 polynomial matrix from a single row vector, I have written a simple code using the for loops. We have four data points, so the degree of the polynomial would be 3, and that's why in this loop the power of x is 1 less than the total data points. So we end up with a system of 4 linear algebraic equations, and we can solve equations by any of the previous techniques discussed. For example, Gaussian elimination to find the unknown coefficients. Once the coefficients are determined, we can write the polynomial equation. The new equation fits as it passes through the four original data points. So far, you have seen the manual approach to fit a polynomial equation through some data points. Now, MATLAB has a built-in function polyfit that can do the same job. The same x and y data points are used. Here 3 defines the degree of the polynomial, and we found the same coefficients as with the manual calculations. There are other ways of interpolation in MATLAB, especially when you have to fit your function through many data points. Here, one-dimensional piecewise linear interpolation built-in command is shown. The same data points x and y are used here and interp1 one is for refers to one-dimensional interpolation is used. An improvement to the previous interpolation is the cubic spline, where MATLAB built-in command Spline is implemented for the same data points.